Hello everybody, this is the Squeeze Theorem, which is a part of calculus. It's pretty simple and easy once you get the idea of it. So I have a previous video that I made of the idea of the Squeeze Theorem. So let's do a practice problem. Let's say you have the limit of, let's say, some function, let's say x squared sine, let's say 3x as x goes to 0. Well, let's try substituting or using substitution and plugging in the zeros. You have 0 squared sine 3 of 0, and sine, this becomes sine of 0. Sine of 0 is 0 times 0 is 0. So there's no problem there. But what if you have the limit of x to the fourth sine 3 over x as x approaches 0? Now when you use the substitution, you'll have 0 in the denominator, and that cannot happen. And that's when you need to use the squeeze theorem. We have a sine function, so as we begin to solve this, let's remind ourselves what the sine function looks like. I presume that being in a calculus class, you have already successfully passed both trigonometry and pre-calculus. So this should be easy for you to remember. That's the sine function. And always, since this is y equals sine of x, notice that the amplitude is 1, and every time the amplitude is 1, even if there's a horizontal shift somewhere over here, the range will always be between 1 and -1. And it's going to go on forever, but it's always going to be within 1 and -1. So if the range is 1 and -1, we'll just say that -1 is less than or equal to sine of 3x, which is less than or equal to 1. So let's take one piece at a time. So we're going to start with the trig function. In this case, it's going to be sine. And we put it within the range, which is between -1 and 1, as proven right here. Now we manipulate this until we copy this right here. So we need to have the limit of x to the fourth sine 3 over x as x approaches to 0 right here in the middle, and then solve the limit on both sides and see what we get. So hopefully that'll be clear as I continue here. So we need to multiply everything by x to the fourth. That's the next thing we should do. So x to the fourth times -1 is negative x to the fourth is less than or equal to x to the fourth sine 3 over x is less than positive x to the fourth. And now we just need to take the limit of everything because that's the only thing left. Sometimes there's more steps, and that just means it's more fun. So this is a pretty basic example. So again, what I'm doing is I'm taking the limit as x approaches 0 to both sides. So this is the original function, right? So that means if I solve for each side, that should tell me the answer that I'm looking for. That's negative x to the fourth there. Alright, so we just solve for both sides. I'm just going to quickly remind you that let's imagine this being f of x, g of x, and h of x. Okay, I just want to make sure that you understand, or you could visualize this real quick. So what is the limit of negative x to the fourth as x approaches 0? Well, this is a polynomial. You could substitute. So this is going to be 0. In other words, f of x equals 0. This is going to stay the same. And the limit of x to the fourth as x approaches 0 is, well, 0, because it could use substitution. Now this is pretty much the squeeze theorem, it says that if the limit of f of x as x approaches some number a equals L, and the limit of h of x as x approaches a equals L, then the limit of g of x as x approaches a has to equal L, because g of x is less than h of x, which is L, and greater than f of x, which is L. So it has to be squeezed in between L. Now, let's, to remind you, here's A, and here is L, and as, let's just do this, as you approach closer to A, the limit would be L, right here. So it says that the limit of this function as x approaches 0 is less than 0 and greater than 0 at the same time. The only option left, or the only thing it could be, is 0. Therefore, we have solved the limit. It is 0. And let's draw what this looks like right here. Okay, so what this is going to look like is, it's going to be like a asymptote-like structure right here. This is x to the fourth and negative x to the fourth. X to the fourth is the upward parabola, and negative x to the fourth is the downward parabola. And the sine function in between is the function that you're looking for. It's going to look something like this. And as it approaches 0, it has to be squeezed between 0, and this is like the epitome of the sandwich or the squeeze theorem in calculus. So thank you very much for your time.